Hey there, today we'll be doing this question that appeared in LeetCode Weekly Contest 326 2522 partition string into substrings with values at most k. The given question statement is you are given a string s consisting of digits from 1 to 9 and an integer k. A partition of a string s is called good if each digit of s is part of exactly one substring. The value of each substring is less than or equals to k, and we need to return the minimum number of substrings in a good partition of S, and if no good partition of S exists, we need to return a -1. So what do we mean by this question statement? So let's just take this example right here, that is S is equals to 1 6 5 4 6 2, and for now k is equals to 60, right? So what are we going to do? Let's just directly jump on to the approach part with the intuition as well. So the intuition would be to just greedily take all the numbers one by one such that the numbers are less than or equals to 60. So what are we going to do? We're just going to greedily take a number one by one, because they have said we need to return the minimum number of substrings that we can form, right? Such that every number is less than equals to k. So we first of all start by taking 1 as our number. Now we see that okay, 1 is less than 60, we can increase our size. 16 is less than 60, well enough, we can take it. Now we go on to 5. By taking 5, we see we are forming a number 165 which is larger than 60. So we cannot take this. So we'll restrict our numbers window till here. Now we start our new number from the next index, and so on. We go on by forming 54 for the next index, because by taking 546 you'll be exceeding the bound of k, right? So you cannot take that. Now again you can just take 6 and then n 2, right? So this is the pretty greedy way in which you can do it. Now also there must be a case where let's just say your number is something like, let's just change this to 9, and let's just say our k is equals to 1 for now. Fine. Now you'll see this is an edge case where you just need to take care of that. If any value is lesser than, if you find a value which is greater than this k right here, then you'll never be able to find it. And what do I mean by that? By that I mean, see, our k is 1, right? So whenever you try to go and try to make a substring, let's just say as our number is right now 119, something like this. Fine. So you can well enough go and make this right here, because 11 will be greater than 1, right? So we cannot take 11. Now you'll try to make this as a particular substring. Now you come on to the third index and you see that 9, even if you make this single number as a substring, it will still be greater than this one, and this will be violating our condition, right? So this is the edge case. You just need to see that if any number that is present there in your string is greater than your k, then you can never actually make a substring. And this is only valid for the numbers from 1 to 9 right here. Okay, so that means if any number, if any value of k which is greater than 10 is there, you need not check this condition. Fine. Why so? Because at a particular index you can only have values from 1 to 9, right? If you are taking two indexes, then it will be having a value 10. So you are just needed to check for particular indexes. If its value is greater than k, then you can never do it, but if it's not, then you can do it. Now let's just change this to 10 right here. Now let's just understand how we are going to approach this problem through code, and let's just dry run this once again, and it will be pretty clear to you, and you'll be able to code it yourself also. So let's start it from the first index itself. So your value of k is 10 for now. So what are we going to do? We're just going to maintain an index. Fine. And let me just open the code right here. It will be better for you to actually visualize it. Keeping aside the edge case that we had learned about, and we have actually written it above. Okay, just for now, let's understand how do we do it for greater than 10. And the edge case is pretty simple. I'll show you it again. Fine. So for this, let's just say our k is equals to 10. And how do we go about doing it? We simply say that, okay, I'll be taking my number. I'll be just forming my number one by one by taking every number. So at first, we are at index 1 and we'll be forming a number 1. Okay, and it is less than 10. Well and good. So this is the part where we are forming our number. Fine. And this is the part where we are checking if it is greater than k, then we do something, but it's not greater than k, right? So we do not do anything yet. Fine. So now we go on to the next index and we form 11. The number is formed up till here. Now we go on to this if. Why? Because it is greater than k, 11 is greater than 10. So we go on to this index and we decrement our I pointer. And why do we do that? See, because we were here, right? We were here and we formed 11. That is perfectly fine. But this can never be taken as my substring. So I say, okay, since I cannot take this index as my substring, what I'll do is I'll move one step back. Fine. I'll just say that, okay, I'll be moving one step back. And this is what I'm doing. I'm just saying that, okay, I'll just move one step back and I'll make sure that my number becomes 0 again. That means I do not have any number in my hand. So my number becomes 0 again. Now we'll go on to this part and our I will be incremented again, right? So see, this is just the beauty of the code. You just do an I minus minus here and you say, okay, I'll just take one step back. But again, when you come to this part, your I will be incremented, right? And you'll move on to the next index. Coming on to this, now you'll see that, okay, again my number is being formed. So what do we get? We just get 1. Fine. After that, you see 1 is greater than k, obviously not. So you just move on to the next index, that is right here. You just move on to this index and again what do we see? That, okay, we need to form our number, that is 19, and 19 is greater than k. You again move on to this one and you just say what? You just decrement your value of I by 1, right? And where do you go? So after decrementing it, your index will change and you'll just move one step back. So this is just the normal approach. You could also do it by another approach. It is perfectly fine. I just approach it like this, that whenever I'm seeing that my number increases by k, what are we doing? We are just moving one step back and we are making sure our number is initialized to 0. That means when I come back again to my next index, I'll be making my substring from this index, right? And every time we are finding that a number becomes greater than k, we are just simply incrementing our count by 1, right? So this whole part is clear on how to do it. Now let's just see the edge case code that we have. So our edge case code will be very simple one. We just see if all the values of k is less than 9, it is not a problem, right? But if I find any value which is greater than k, that is given to us, we just return a -1 as explained, right? So if you have something like, let's just say 9 and 7 and your k is given to as 1, you see that this can never be a possible substring, so you just return a -1. Fine. So this is the whole code walkthrough, and if you do want the code, it will be there in the description link as well. And also I have already submitted this code, so no need to worry about that. Fine. So yeah, this is it for this one. And if you did understand the explanation, please like and subscribe. And yeah, thank you.